I'm very happy and want to thank first for the organizers to giving me opportunity to open this interesting seminar. My name is Timo Vesala. I studied physics in University of Helsinki. One day I started to investigate ecosystems. I'm working still in University of Helsinki in Kumpula campus, but I have a second office in Viikki campus in forest sciences. I'm a member of a Finnish climate panel. My title is very generic and I have a half an hour time. I cannot offer you all-inclusive hotel, but I try to offer you a room with a view. And this is the content, saying something about the greenhouse gas emissions and sinks, then focusing on land area vegetation, also saying a little bit on freshwaters, lakes and rivers, wetlands, peatlands, and then in the end also to look a little bit the concept of natural climate solutions. And then feedbacks and responses, feedbacks of the biosphere to atmosphere. Let's start from the slide where there's a lot of information. I'm just picking up there a few things, and this shouldn't be surprising for anyone. So there are 3 greenhouse gases, not saying anything about water vapor. There are 3 greenhouse gases, carbon dioxide, methane, nitrous oxide, of which concentrations in the atmosphere human beings have affected a lot. And it's a scientific fact that these gases, more there are those in the atmosphere, there is a potentiality warmer is the atmosphere. So they are really enhancing so-called natural greenhouse effect. And they have, during last 150 years or so, the concentration of them have increased dramatically. Here is a 1750, and here is a concentration in certain units for these gases. You see a very dramatic thing. I will not say more about nitrous oxide, which is also known as the laughing gas. Just to put it very simple, more there is a nitrogen in the soil, the bigger are typically the nitrous oxide emissions. And this is very true, especially for the agricultural land areas. And I'm now more focusing on the carbon dioxide and methane. And here you also see that during last 10 years or so, this is the increase rate per year of the concentrations. And visually it looks like it goes very quickly up. Let's start from carbon dioxide. Human activities in general are producing carbon dioxide. Highest emissions are from industrial areas and densely populated cities. Here is a map of Europe, and the red color is indicating carbon dioxide emissions, and dark red really meaning that there is a very high emissions. And you see how it's very much concentrated in these very densely populated areas in Europe. You can also pick up the individual big city areas and so on. If you are wondering that here are maybe big emissions in eastern Finland, this is just a blurred picture because of the resolution. So the lake area in Finland is not emitting really very much. So here is really these high emission areas. This is the global view. There's a lot of information. I'm picking up there first here on the left. There is the carbon dioxide emissions from the human beings' activities, and there are also some numbers. The units, you don't need to care about that. They are gigatons of carbon per year, but just you can look the numbers, how high they are. Fossil fuel emissions are contributing roughly 90% to carbon dioxide emissions, and less is related so-called land use change, which is, for example, destroying forests. But then the all CO2, carbon dioxide, what is emitted, it's not staying into atmosphere. About 1/3 at the moment is uptaken by land areas, especially forests, forest vegetation and forest soils everywhere in the world. Similar amount is also taken by ocean. And then about the half is staying in the atmosphere about these original anthropogenic emissions. One thing which is very important to note, that if you look the storages, how much there is a carbon in the soil, in the ground, in land areas. This amount is huge compared to this uptake. So the yearly uptake is only about 1 promille of the storage. And why this is important? It means that this system is very sensitive to small changes. So if there is a tiny differences how the carbon storage in the vegetation and soil is changing, it may have a dramatic big change in the uptake. And also what is important to note, that this so-called net uptake is a tiny difference of the two processes which are much, much bigger. Another one is uptaking carbon, that is the photosynthesis, and another one is a releasing carbon, that's a respiration, which is coming from the soil and all living vegetation. And they are order of 10 times bigger than this uptake, meaning that if one of these is a little bit changing, it has again the dramatic effect, much bigger effect to this net exchange. This is very important to note. And then how these things are distributed in the world, I'm only going through this part of this figure. So you recognize there the land areas, and here is again the color coding, so that red means emissions and the blue means a sink. And now we are not talking anymore on anthropogenic emissions, not the human activities. This is just the natural or semi-natural vegetation. And what you see there is that the map is really dominated by sink almost everywhere, excluding, of course, the very dry areas and deserts like the Sahara there. But you may also note that there are some red spots, almost the whole Australia, Southern Africa, and then the northeast South America, which are very much related to the droughts and fires. But otherwise, the land sink is very ubiquitous. Then what is the interesting thing is that, okay, I put this back. So I just very briefly say that here is also ocean sink. And there you note something, that the tropical waters are on the average quite big emitters of the carbon dioxide, and then southern and the northern waters are the big sinks. And here is this sink presented for land areas and here for ocean. And bigger the number, the bigger is the sink. Here is the time span of the 40 years. Here you see that for land areas, there is a lot of interannual variability. So years are not brothers. Vuodet eivät ole veljeksi, as we say in Finnish, for the land sink. And this huge variation, even some years it could be that there is no sink, that it's a net emit to the land areas. It's very much driven just by weather. So what kind of temperature, what kind of humidity, what kind of rain you have everywhere in the world, this is driving this. You still see that there is a persistent increase, and this is just coming, if I put it very simple, more there is a carbon dioxide in the atmosphere, more it is also absorbed. But there could be somewhere in the future some limits, and this system may start to saturate. And the same is also true for oceans, although there is not so huge interannual variability. Oceans are much, much more stable if we are looking in the timescales of the years or even tens of years. That was the vegetated areas. What about the freshwaters? And there are a lot of different kinds of freshwater bodies. I saw this one. This is very recent publication, and there was a collected data from the different type of lakes and reservoirs in the world, not very good coverage of the whole world, but the data measured by certain type of the methodology. What you see here, and you don't really need to read carefully these individual plots, just look the colors. So the more orange, the higher emissions, and more blue than the some sinks. Dominantly, all waters in the world are on the average emitting carbon dioxide. This is often could be for Finns especially, also maybe for Swedes, although we have more lakes than you per square kilometer. Your number is bigger, but it doesn't matter. The square kilometer is more important. So it may be the inconvenient truth for very many that our pristine or now lakes and rivers, they are emitting carbon dioxide. The absolute number is not very big, how much they are emitting compared for the sink of the forest, but they are over the year, excluding ice-covered period, they are persistent emitters, and they are doing with small emissions all the time, every second, every hour, if I a little bit exaggerate and put it simple. And it has been estimated that typically everywhere in the world, about, or especially boreal region, it has been estimated that about 10% of the carbon uptaken by forest is released back into the atmosphere by lakes and rivers. 10%, is it much or not? That's a very good question. But that's the view at the moment. Then what about wetlands? And what are wetlands? Suo in Finnish. So wetland is an ecosystem where the water level is very high, but it's not a lake. And they are typically containing a lot of the carbon stored in mosses. And the water table level is very important. And the water locked system also means that there is not very much oxygen available. And in this kind of conditions, when this dead organic material, mosses, roots of plants, litter, when they are decaying, they are decomposed, it's not only produced carbon dioxide, but also methane. So the wetlands are typically hotspots of the methane emissions. And methane is a much stronger greenhouse gas than the carbon dioxide. Here's a little bit complex picture, but I also want to tell you one curiosity, which could be interesting. Here is a northern latitude zone, so here is a North Pole, Finland is there, Greenland, Siberia, so on. And the more we move in color code towards yellow, higher methane emissions. And then what you see there, you see that there are really hotspots practically in every map, especially in very peatland-dominated areas like Scandinavia, Canada, and especially Western Siberia. These maps are not identical, and there is a big uncertainty related to where really the biggest emissions are. And this now comes this point for curiosity. Uncertainty is coming very much on that we don't know where the wetlands are located. We don't know how high the water level is in different parts of the northern region. So simple, but very challenging to get this information scientifically. And that's bringing the huge uncertainty for modeling. So these maps are made by models, because we don't have a so good coverage of the ground observations. So this kind of things are still kind of, the scientific community is lacking that kind of information. The methane is also very much coming from other aquatic ecosystems also. So wetlands are aquatic ecosystems, they are not lakes, they are not rivers. About half of the world methane emissions are coming from wetlands, and second half related to natural ecosystems is coming from the lakes and small ponds. Now when I mentioned already that methane is very strong greenhouse gas compared to carbon dioxide, there is that kind of important difference, that carbon dioxide, it's a lifetime in the atmosphere, it's thousands of years. So it stays there very long, whereas a methane, a lifetime in the atmosphere is much shorter. So order of the 10 years, because it's chemically reactive. And in the long term, although the wetlands, if you take the snapshot, for example, 1 year, typically wetland, although it's a carbon sink, it's a heating atmosphere because it's emitting so much methane. But if you take the time span of the hundreds of years, thousands of years, the carbon dioxide effect will win and dominate, because they have absorbed so much carbon dioxide away from the atmosphere, and it's stored there for the long term. Then I move to second part, which is related to natural climate solutions, and back to carbon dioxide. As I showed, we have carbon sinks everywhere. Could they have some, what kind of role they could have in the battle against the climate change? And there is that kind of concept, natural-based climate solutions, which are simply meaning that, as we know that there are different ecosystems are acting as a carbon sinks, is it possible that that by human activities you can pay attention how you are, for example, managing or using them, and to try to maximize the amount of carbon which they are uptaking, and especially what is also important, in the way that the carbon is staying there for a long time, at least hundreds of years or even longer. So this is the idea. And here is a schematic graph. Here is 50 years, so we are partly here in the future. And here is global carbon emissions, and here are historic emissions. And if you continue business as usual, the emissions are just going on. But if we have mitigation actions, so we should dramatically start to decrease the emissions very soon if we want to be this 2 degrees pathway, so that the global warming is not within this century keeping within the 2 degrees, or in fact the half of this century. And then natural climate solutions may have there some role. They would help also in this battle against the climate change. And there the forest played a very big role. I will skip over this slide, just noting that paying attention to forest everywhere in the world could be also very cost efficient. And what we could do in Finland, and this slide is very much also along some recommendations by Finnish Climate Panel, also Luke Institute. And if we would think these natural climate solutions enhancing sinks, the lowering harvesting by 10-20%, what is at the present level, would be smart. Also the increasing rotation time is meaning that forests are cut when they are older. And then also to pay attention to this kind of things, although this don't play so big role in Finland at the moment, but they are very important if you go to more to the for example, forest outside Europe. But then there is some warning things that if the climate is changing, it may bring their so-called stress factors. So, for example, droughts, which are really diminishing the things. Also, there are, although I said it would be smart to decrease the harvest levels, society at the moment is very much maybe going even to the increasing harvest levels for reasons which are more political, economical, from climate point of view, not so smart. And then also when forests come old, although they are really having very high stocks of carbon, the capability of the absorb carbon is decreasing. But this is something which comes really to issue after, let's say, hundreds of years time scale or even longer. So this is not really the discussion point or important discussion point at the moment, for example, in Finland. I skip over that. I say very shortly that in all of these things, because my view had been very much narrow-minded natural sciences, we must of course keep in mind all kinds of social, political, cultural things, remembering also the food security when we are thinking how we manage different ecosystems. And I'm stopping here, maybe quickly concluding that and stressing here now that although I was talking about this keeping things and high level, the first thing is that we should reduce the fossil fuel emissions. This is the starting point. But besides that, we may also pay attention to keeping things. And the land vegetation is practically sink almost everywhere, but remember disturbances, fresh waters are emitting carbon dioxide everywhere, wetlands, methane, although they are huge carbon storages, and then natural climate solutions really can play a role together with fossil fuel emission reduction, especially for the forest, would be even very cost efficient. And still, there are a lot of the uncertainties and challenges related to these things. Thank you.
Thank you very much, Timo, for an excellent introduction to the topic and the theme and the seriousness, and also to sticking to the timetable, which means that there is ample time for questions. So if anyone has any question or comment, now is your chance. Yeah, I will bring the microphone to you.
Hello, thank you for a nice speech. My immediate question that came to mind was these things, how much do they affect the climate compared to the fossil fuels? How important is it to keep the things in order compared to lowering the fossil fuel emissions?
Yes. I skipped in this slide the right hand. So in Europe at the moment, or EU countries, about 10% of the fossil fuel emissions of carbon dioxide are uptaken by forests. So in Europe, it's a 10%. If we go back to this global picture, there it's 30%. So of course in Europe it's a smaller, although in Europe we have a lot of forests, so Europe is also the hotspot of the emissions. And if this is the global view, and then this is including all large areas of the forest where are not very much emissions. So then this percentage is 3 times bigger worldwide. What is it in Europe? It depends also very much on the spatial scale. What are you looking?
Yeah, thank you. There was a question from Kari Raivio here.
You mentioned that this issue of how much to harvest is a political and economic issue. But it's not only a question of how much you harvest, it's also a question what you do with the harvested wood. And today, what is happening in our wood industry is that most of it is thrown into huge factories to be cooked into cellulose and then sold as a bulk, very low degree of sort of product sophistication. But the carbon in cellulose appears in the atmosphere on the average in 2 years. But if instead of cooking it into cellulose, one would make sort of longer term wood products for wood construction, building and so forth, then the time of appearance into the atmosphere extends to 35 years. So this is something that discussion of cutting forests and what to do with the wood has not been much emphasized, but I think the wood industry should look upon its strategies in the long term, because that's an important aspect of this.
Yes, I can, although there was no question, thanks for the comment, and you have made your home lesson very well. The numbers you gave, they were exactly correct.
Thank you.
And also to maybe comment that what is very much also sometimes surprise and inconvenient truth is that it's exactly as you said. If we would change the present product palette so that building up of the wood houses and so on, and replacing cement and concrete, that would certainly have a climate benefits. But if we would keep the palette otherwise same, but increasing wood buildings at the cost of bigger harvests, that wouldn't be climate beneficial even in the order of hundreds of years. So people are sometimes thinking that it's fine that let's harvest more and then to build the buildings. This is not the way, and this is often really something that is surprised, and very many people are ready to deny it even, because they don't want to hear something like that.
Sorry, there was one before. No, give your short comment.
Most of the cellulose sites you use this young forest, when you use this sort of for construction where you can keep it, you need this big timber. So that's really, and you get both in forestry. You have the most valuable is the big forest, which you can use in forest. You should use more of this. But for the cellulose, you use this young timber, which is got by thinning. So I think this is important to keep in mind, that you have two different raw materials. Thank you.
Yep. So thank you for a nice presentation. I would like to ask about the wetlands. Det är våtmarker på svenska.
Yeah.
And there is a movement now, especially about the youngs, especially in Sweden. Återställ våtmarkerna. So what is actually the meaning? Because you talked about the methane and the CO2. Can you explain that? Is there any sense to it?
There is, but it depends also the wetland type, and especially the nutrient status. Dominantly, it's a climate-wise to restore wetlands. For some wetlands, could be also maybe reasonable try to forest them. So you can also to get rid of the drained peatlands, either restore them back to the wetland or then to forest them. The problem of foresting them is that you get rid of the methane emissions, but you typically trigger very huge carbon dioxide emissions from the peat when the water level is going down. But how high are the carbon dioxide emissions depend on the nutrient status, and the pure nutrient peatlands could be also possibly wiser to forest them than to restore. But restoration is fine, and this carbon dioxide sink will already win the methane emissions even on the time scale of the, let's say, the 100 year.